Dividing is just multiplying, yes? You all already know that 3/4 divided by 5/7 is the same as 3/4 times 7/5. Yes? Of course you are. And you are already aware that the root of 2 times the root of 7 is the root of 14. You already know that. Why? Because these two share indices. Yeah? Yeah. The plural of index. Just like codices is the plural of codex, which you all know from watching Da Vinci Code. No. In the Da Vinci Code, they find a codex. If you find more than one codex, they are codices. If you find more than one index, they are indices. Anyways, back to business. Since multiplying and dividing are so similar, multiplying and dividing radicals must also be very similar. You people are intelligent people. What then here, if I change this to root 14 over root 2, must the answer be? Root 7. It has to be, because you already know root 7 times root 2 is 14. You must know that the inverse operation is true. Yeah? Yeah. So, you already know how to do A, don't you? What's the answer? Root 6. Excellently done. You already know how to do B, too. Kind of. Because you... First of all, if this wasn't there, what would you do? Oh, wait. Good gravy. What's gone on here? X. If none of this was here, do you know what to do? Of course you do, because you already know your exponent laws, and you know that dividing these, if they have the same index, is just division, right? So if you know how to do that, then you must know how to do everything, right? Just like in the exponents issue, when we had 14x squared y over 5xy, you split it up, right? So what are we going to do here? Split it up. Why are we going to split it up? Why will splitting it up work? Because math is always the same. It does not matter what it looks like. What is 15 divided by 3? 5. 15 divided root. Not that. That makes it look like the index. 5. What is 15 divided by 3? 5. What is x cubed divided by x? Squared. What is y squared divided by y? Y. Would you leave that answer as a final answer right now? Why not, Sean? Because that x can be moved out to where? Why? Because it's x squared. So that is 5x root 5y. Yeah? Nothing new. Easy peasy lemon squeezy. Yeah? Everyone agrees? Going once. Going twice. Going thrice. Never is. Say it nice and slow. Take all the time I need. Wait. And then when I get there, but wait. No matter what. Every time. I tell you, it's enough to make a guy sad. No, it's okay. I'm used to it. Now, Suhani, may I stop waiting now? I may? Okay. I was just using my time there. Everyone is good? Oh, wait, yes, Jasleen? Yes, indeed I did. Anything else? You know what? I don't believe you. 45 root 28 x to the fourth y cubed over not 9 12 root 18 x y to the third. You guys do that one. There is, what? It's just x. It's cubed. You guys go ahead and monkey around with that.
They're both divisible by 3.
Oh, they're both divisible by 3.
Y cubed. You guys go ahead and monkey around with that. Huh? Do exactly what we did with B. Now we'll see who actually looked at their notes and or wrote out what to do. Ha 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 ha. Are we ready to go yet? What is one thing you could do right away first, if you wished? Simplify what? Pardon me, Preston? You could do this division, yes? Okay, what is something else you could do? I'm not saying that's wrong. I'm just saying there's another thing you could do. What else could you do? Suhani? You could simplify each radical, right? What is something else you could do? Could you do something with 45 and 12? Brendan? Yeah. So there's all kinds of things you could do to start, yes? Oh, Selena, do you have something else? You could. That would be a really bad thing to do. Yes, but it would be a really bad thing to do. So, give me a, what should we do? I would, if I were doing this question, I would simplify these radicals first. I would say that that is 7 times 4. So what would come out? 2. And any x's? 2 x's. And any y's? 1 y. So what would I be left with? I would have 90 x squared y root 7 y. Right? Over, what can come out here? That's 9 times 2. So what comes out? 3. And a y. So I would have 36 y root 2xy, correct? Then what? I have an answer.
Okay, so you know how you have x squared?
Yeah.
Wouldn't that become like just x?
Why?
Because like, okay, sorry, I meant the y. wouldn't that just should we just take that out?
Which y? I can see 4 y's written in this.
Y cubed divided by y cubed is 0.
We're not taking out a y. Well, you could if you did that way. I'm doing this possibly in a different order than you. So, no, that's not the answer. Because what can I do with 36 and 90? Divide what? They both divide by what? They both divide by 9, right? Yeah. So that's going to be 10 over 4, which, does that not get smaller? 5 over 2, good. 5 over 2. Anything happening to that x squared out here? No. What about that y? It's gone. Root 7 over root 2, because 7 and 2 don't do anything together. Anything happen to that x? No. Anything happen to that y? It's gone. That is as far as you people can go right now. And there's a reason I gave you this question that ended right here, because it leads directly to this, the nature of radicals. This is true. A radical cannot be left as a denominator. That's the fact. I want you to tell me why. Why is this not okay, do you think? I haven't told you. I would like to hear your ideas as to why I cannot leave that. Talk to your neighbor. Go.
I don't know. Wait,
Hawaiian shirt, so I'm hula. I know. Now, there are a couple of people in here I know that already know what to do with that. But that is not the question right now. The question is, why do we have to do that? I don't care that you've been taught what to do. Anybody can be taught what to do. I could teach my grade 7 daughter what to do here. If you see something that's written like this, you need to do this. Does that mean she knows anything about math? No, that means like a horse, given the right amount of apples, she can be taught to count. So, why? Selena.
Because it's an unknown and you can't divide by an unknown number.
So you're saying I can't leave this in math? No, it's fine. I appreciate your chance to ask.
I mean, if you want to figure out what x is, I guess.
How could I figure out what x is there? It doesn't equal anything. Okay. So, but, wait for it. Keep your hands up if they're up. You are on the right track. You're like the dog in cartoons following the rabbit tracks, and then he starts following the train tracks, and then Bugs Bunny says, "What are you doing?" And the dog says, "I'm looking for rabbits." And Bugs Bunny says, "But you're following train tracks." And the dog says, "Huh?" And Bugs Bunny says, "If you're following train tracks, you must be looking for a train." And the dog says, "I am." And then, train hits the dog. Preston.
Just going off of what she said, is it because x might be 0?
Oh, you're close, but again, there's an x there. Yes, x can't be 0, but I'm saying even this isn't allowed. There's no x on the bottom. Suhani.
Is it because the denominator always has to be a whole number?
The denominator has to be what? A whole number? Okay, so you're saying that this wouldn't be allowed. 6 over negative 7. Negative 7's not a whole number. Okay. Now you're even warmer. Because, of course, would this be allowed? 1.2. So that's not an integer. So why is that okay, but that isn't? Wait, who's next? McKenna. It has to be a rational number. Why? Ah. No. Selena. Yes, now we're on the right track. How do you do 6 over 2? What is that? Thank you. That is 6 divided by 2, correct? 2 goes into 6 thrice. Yeah? Okay. What if it was 62? Now what would I do? 6, 0, bring down the 2. How many times 2 go into 2? Once. 2, 0. What if it was 628? Yes, it's grade 4. How many times?
4 times.
4. Everybody cool? And what happens now? It ends. There's no remainder. Agreed? Okay. So what is that? Don't. That's not what I'm asking, Suhani. What is that? That is the root of 2 divided into 6, yes? So what do I do?
How many times does the root of 2 go in?
What's the root of 2? A number that goes on for how long? Ever. You cannot do this because you cannot divide by the root of 2. Now somebody says, I will write this. And somebody will say, oh, it's not allowed. Is that allowed? Of course it is. Why? Because the root of 25 is not irrational. What is it? 5. Aight? Aight. Now, why can't we leave them? Because we can't use irrationals in the bottom. I should have said denominator, because 6 over root 2 equals root 2 into 6. How do you know to divide it? Everybody cool? All right.
Mr. Myers, so you know how like the answer for the question that we did together?
Yeah.
That's like the answer to the water, right? Like that technically that's wrong.
This is no, it's not wrong. It's not done.
It's not done. But if on like when we have it on a test, we're gonna be.
I'm about to give you the tools to deal with this.
Oh, okay.
All right. So, how do we fix it? Now, I cut Suhani off like a meanie. Suhani, how do I fix it?
You multiply like the by the bottom, so you would get 6 root 2 on top and then 2 at the bottom.
Yeah. Yes, exactly. What you do here is you use the conjugate. And you're about to learn what that is. The conjugate is, actually I shouldn't have said that yet. If you're writing in pencil, erase conjugate. You must eliminate the radicals. You have 2 choices. One, you can use multiplication. Or 2, you can use the conjugate. The conjugate is when you have a binomial, and this is what the conjugate is. A plus B is normal. The conjugate is a minus b. If I start with x minus y, what's the conjugate? X plus y. What if I start with 3m minus 4n? What's the conjugate? 3m plus 4n. Right? In the middle. Everybody cool? Preston.
If it's a divide, then it's going to multiply it. If it's 3m divided by 4n.
If you add 3m divided by 4n in the denominator, like this, please don't write this down, ladies and gentlemen. If you add 3 over 3m over 4n, that is 3 divided by 3m over 4n, which is 3 times 3n over 4n. Oh, sorry, 4n over 3n. Sorry. So it would take care of itself anyway. You're borrowing problems from the future. We'll talk about that in a sec. So, what is this conjugate? Root 17 plus 3 root 14. What is this conjugate? Root 34 minus 4 root 2. What is this conjugate? Doesn't have a conjugate, so it's got to be the other one. What is it? Just root 5. Because that will eliminate. What? What are you talking about, Mr. Myers? Watch. Root 17 minus 3 root 14 times root 17 plus 3 root 14. What do I need to do here? I got to distribute, yeah? Which we've already done, yes? What's root 17 times root 17? 17, right? Who just said what? Okay. What is root 4? Stop. What is root 4 times root 4? Root 16. What is the square root of 16? 4. What is root 2 times root 2? Root 4. What is the root of 4? 2. So, what is root x times root x? X. So what is root 17 times root 17? 17. Plus, what's this? 3 root 17 times 14, correct? Right? 17 times 14. Then what's this one? Minus 3 root 17 times 14. What just happened? Plus 3 minus 3. Gone. And what's last? 3 times 3 is 9. Root 14 times root 14 is 14. 9 times 14 is 126. 17 minus 126. And now, all of a sudden, I have negative 109. So if this was a fraction, that wouldn't be allowed. But if I multiplied by that, I get that as a denominator. Okay? So, if I multiply, I'm going to show you why. Don't worry. What does that equal? 1. Why does it equal 1? Both the denominator and the numerator are the same. If I multiply something by 1, does it change its value? No. So have I changed this side's value by multiplying by 1? No. What have I changed? How it looks. I have a denominator that I can work with, and my numerator is root 17 plus 3 root 14. Here is why it works. Again, you needn't write this down. You know that that doesn't work, correct? Because root 2 cannot divide, that looks like a square root sign, cannot divide into 6. because this number goes on forever, yes? Okay, so since that's not allowed, I would get rid of it, right? By multiplying by 1. What is root 2 times root 2? 2. And on top, I have 6 root 2 now, correct? So now, I have 2 dividing into 6 root 2, correct? That we can divide by 2. Because there's 6 root 2's, divide it by 2, there will be 3 root 2's left. Everybody understand? That's why we're allowed radicals in the numerator, but not in the denominator. Because this is doable. If I write out 6 root 2's, I can divide it by 2. 3 root 2's. Everybody good? Okay. So let's come back here. I put the hardest one first. I know that was mean of me. You're going to get lots of practice. You'll see it in a sec. Everybody understands what the conjugate is, yes? Okay. Now let's turn on to page 136. Let's practice it a bit. So what isn't allowed in A? Is it all right to have a 3 in a denominator? Is it all right to have a root 7 in a denominator? No. So what do I have to get rid of? The root 7. The 3 can stay, can't it? So I need to multiply this by root 7. But if I multiply by root 7, that's going to change this value, isn't it? But if I multiply it by that, which is what value really? Root 7. What is that value really? 1. If I multiply by 1, does that value change? Does the value change? No. Does the looks change? Yes. What is 2 root 6 times root 7? 2 root 42 over, what's 3 times 1? 3. And what's 7 times root 7 times root 7? It's the root of 49, which is 7. What is 3 times 7? And now I'm done. Does everybody understand? You can't simplify it. Where would you simplify, Selena? Because you're actually asking me the next question. Because I was going to do that thing that I do. Why don't I simplify? I got 42 and 21 right there.
No, I mean like the 42.
I know. That was my first thing I was going to ask. Why can't I do anything with 42 and 21? I know, Selena, but I'm asking why I can't do this. Because it looks like I should be able to. 42 over 21 should be 2. But it's a radical. So now we do the next thing that Selena was talking about. We simplify 42. What's 42? 6 times 7, 2 times 3 times 7. Any pairs? So I'm done. Everybody cool? All right. Look. Yes, Catherine.
Why are you timesing it by 7 now? Like, when you times it by square root
Okay,
of 7,
because I was kind of hoping that everybody would remember yesterday. 3 root 7 times root 7 is technically 3 root 49. What is the square root of 49?
It's 7.
7. Because root of anything times root of anything is the radicand. Cool?
Okay.
All right. What's wrong with what's wrong with B? I don't like the 6. Is the 14 okay? So what am I going to multiply by? Not 6. Root 6 over root 6. Because I'm allowed to multiply by 1. It doesn't change the value. Kanika.
So, like, this might sound dumb.
No, it won't.
Okay, so do we basically always multiply by the denominator?
No. Stop saying that. Don't look for shortcuts. Look at what we're doing. Okay? Don't say that. What am I trying to do here?
Try and
Get rid of the radical. That's your goal. Everything else comes after that. So in this case, only thing I need to get rid of is the radical, so I'm going to multiply by the radical. All right? So, what is the top now?
7 root
7 root 30. Why is that 30? Just to remind you from yesterday, 5 times 6. Now I'm going to give you an assignment today that covers multiplying and dividing, because I didn't give you a lot of practice on multiplying yesterday, right? Okay, over what? 14 times 6. Because, why? Because root 6 times root 6 equals root 36, which is 6. Now I simplify. 7 root 30 over 14 times 6 is 84. Is there any simplification to be done here? Yes. Where? 7 and 84. How many times does 7 go into 7? Once. How many times 7 go into 84? 12. And now I'm done. Ganika.
7. I don't understand why the 12 would be in the denominator.
Simplify that.
Okay. Because the 1, okay, yeah. I understand. Yeah. Okay. Thank you.
What's wrong with C? Well, I don't like the 18. Now stop for a moment. How will I get rid of that 18? I would multiply by root 18 over root 18, wouldn't I? Isn't 18 times 50 a big giant number? Who wants to factor that? Not me. What should we do first if we can? Simplify. What is this really? 6. That's 25 times 2. 5. That's 9 times 2. What's this up top? What's coming out? 5. So what do we got? 30 root 2, correct? What do I got here? 15 root 2. What's 30 divided by 15? 2. What's root 2 divided by root 2? 1. So the answer is 2. I didn't even need to deal with that denominator because I simplified first. Everybody cool? Now, if you just learn steps, then that thing that took us 2 steps when we're thinking about it, don't write this down, would look like this. Okay, root 18 times root 18, that's going to be 5 times 18, which is going to equal 90, and that's going to be 6 root, oh man, 900. Okay, 900. Oh, I know that that's root 30, so that's going to be out comes 30. That's going to be 180 over 90. That's going to be 2. If you like that better, do that. I don't. That was much better because it happened to work. 50 times 18 was root 900. What if it doesn't work? Like, say this very next question. 60 times 27 is a big old number. So what should I do first? Simplify. What's that top one going to be? 30 times 2. That's okay. Except isn't 30 15 times 2 times 2. So what's coming out? A pair of 2s, so a 2, right? So my numerator is what? 6 root 15. What's my denominator? 9 times 3, what's coming out? 3. What's already out there? So I got 6 root 3. What's 6 divided by 6? 1. What's root 15 divided by root 3? Root 5. And I don't need to rationalize because the denominator was taken care of in the simplifying. I don't ever need to rationalize. I don't need to do this step because I simplified first. Everybody cool? This step is called rationalizing the denominator. And I must do it, denominator, because I am not allowed an irrational number in the denominator. So I rationalize it. Everybody good? All right. What's weird? What do I need to get rid of an e? The root 3. So what do I got to multiply by? root 3 over root 3. Anything different? There's different math, but does the rule change? No. So my denominator is now what?
Nothing.
No, my denominator is 3. And my numerator is what? 6 root 6. Root 9, which is 3. Everybody cool? Now, I'm happy if you leave it there, but you could go one step further. This is 6 root 6 over 3 minus 3 over 3, correct? So what's that? 2 root 6 minus what's that? 1. That's the best answer. I'm happy if you get to there in grade 10. Everybody cool?
Wait, can you explain that?
Which?
Like, how did you...
What color ink has lost you? Blue or green?
Green.
Okay.
So, yeah, how did you get the 3 over 3?
3. Wait.
What's the 5?
Wait. Just wait. What's 6 minus 4?
Where did you get the 4
Just
from? 2.
what is 6 minus 4?
2.
2 over 2. What's 2 over 2?
1.
1. Cool? Okay. 6 over 2 minus 4 over 2. Isn't that 6 over 2 right there? 6 over 2 minus 4 over 2. Cool?
Oh, okay.
What's 6 divided by 2?
6 divided by 2 is
3. What's 4 divided by 2?
2. 2.
Is 3 minus 2 1?
Yeah.
So if this equals 1 and this equals 1, don't these two equal?
Mm-hmm.
Okay, so if this and this must be the same thing then, correct?
So basically, both the numerators go to the denominator.
Yeah, that's how fractions work, right? If you're going to add 3/7 plus 2/3, their common denominator is 21, right? So it's 9 plus 14 all over 21. Yeah? That's all I'm doing here. Everyone okay? You're starting to seem like you're not okay, even though we're not doing anything that is different from fractions back in the day. Right? What don't we like in F?
2.
I don't like that. Do I like that too? That two's okay. Do I like that too? Boo! So what do I need to get rid of? Root 2 over root 2. What is my new denominator? Be careful. 4. Because it is, I think to myself, and I'll do a thought bubble, 2 times root 2 times root 2. Root 2 times root 2, 2 times root 4. Root 4 is 2. 2 times 2 is 4. Everybody cool? You like the thought bubbles? More thought bubbles? Okay. I'll work on more thought bubbles. You know, I've been just saying the thought bubbles all year, right? I don't actually say thought bubble. I say this is what you do here. So I need to add the words thought bubble to everything I teach you. This is how you think. This is your thought. Okay, I'm on it. So up here, I need to distribute. So I use my thought bubble to do root 2 times 3 root 12 to get what? See, before I would have just done that. But now you've got a thought bubble. So, what is it? 3 root 24. And then I got another thought bubble. In this one, root 2 times 4 root 3 minus 4 root 6. Uh-huh. Huh? Okay. Now what? I wouldn't yet. You're right to look at root 24. It should be bugging you. Root 24 should be going, Sean, 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 like pulling on your pant leg. Sean, Sean. Simplify root 24. What is it? I'm running out of room. Thought bubble. That's 4 times 6. Out comes a 2. So what do I got? 6 root 6 over 4 minus 4 root 6 over 4. Hey! 6 root 6s take away 4 root 6s? What's that? 2. So what's my new numerator? 2 root 6 over 4. Hey! 2 over 4 is what? 1 over 2. Would I ever write 1? Root 6 over 2. I'm sorry, guys. The thought bubbles make it much busier. I'll do a hybrid of the two. I will say thought bubble, but not write it down. So that will twig you to say, oh. Okay? All right.
I got stuck on the very last step.
So did I.
6 over 4 equals root 6 over 4.
This is the part where you're stuck? All right. Well, again, you see that we know how to add those. Oh, so you're okay with understanding that this is 2 root 6 over 4? Okay, well, what's that? What's that? 1 over 2. Okay. Huh? You with me? Are you with me? Okay. So this is 2 over 4 times root 6 over what? 1. 1/2. 1 times root 6 is root 6. 2 times 1 is 2. You're just simplifying fractions. Just like we did when it was this. 15x cubed over 5x. You simplify the numbers. 3. Simplify the variables, x squared. Now, ladies and gentlemen, no pressure, but this is the easy stuff. Are we okay? Yeah.
F was square root of 6 over 2. Right?
Square root of 6 over 2. Is everybody okay? Everybody's good? Preston? Don't give me away. Don't give me away. Stop borrowing problems from the future. Is everybody okay now?
Yes.
All right. You don't need to write this down. I want you to think about it. Just think. Again, thought bubble for yourself. 6 root 7 over root 24. Just think about it. What would you do first? McKenna. You would simplify the 24 to get 6 root 7 over root, that is 4 times 6. So what would it be? 2 root 6. Now what?
Now you get rid of 6.
You would do times root 6 over root 6?
Yeah.
Why aren't you caring about that 2, Mr. Levings? Because he's dead inside. Why? I'm just kidding, Thomas. Why don't you care about the 2? Mathematically speaking. Yeah, I wrote root 2. Because it's not a root. It can be there, right? Okay. So what do I got now? Up top. 6 root 42. What do I got in the bottom?
2 times 6.
2 times 6, which is 6 root 42 over 12. Preston! Go, brother!
242 and 3 over 2. Wait, 6.
You got it, man! Bring it home!
3 root 42 over 2.
Preston, don't you touch that calculator, Preston! Preston, what is that?
This is the same thing as
That's why I chose these numbers, Preston. What is that? It's 2 over 4, but it's also what? Yeah! 1 root 42 over 2. Do I write that one? No!
3 over 6. No, 2 over 4.
YouTube fans, you cannot see, but I am giving a very enthusiastic thumbs up to my good friend Preston Cook. Yes. I forgot to last night. Well, if I don't do notes, there's nothing to post. What do you want from me? I run a family of 5. My mother-in-law is dying. Come on, man. I'm doing the best I can here. All right. Now, it's okay. She's old. Old people die. It's not like she's 53. She's 72. Old people die. 72? No, 72 is not pretty young. 72 is pretty young for where we live. Okay? In the Congo, 37 is the expected life expectancy. She's lived double.
Can I share an anecdote?
Please do.
Okay, once I was talking to my good friend Selena. Yeah, I was talking to my good friend Selena over here. And I said, oh, my great-grandpa, who's 99, still goes up and down the stairs, which is a true fact. And she said, that's not surprising. He's pretty young.
All right. Now, YouTube fans, my good friend Preston Cook has asked an intriguing question. What does one do when one is faced with 2 radicals on the bottom? I must multiply by what? What would get rid of the root 15? Root 15. What would get rid of the root 10? Root 10. But if I do plus, there will be a middle term. So what must I do? Oh, damn it! If I do minus, there will be a middle term. So what do I need, McKenna? The conjugate, which is what? Plus. If I have that on the bottom, I can only multiply by 1, so what must be in the numerator? No, you cannot do root 25 because that is not how radicals add, which we talked about 3 days ago. Plus root 10. Now, what is root 15 times root 15? 15. What is root 15 times root 10? Positive root 150, yes? What is negative root 10 times root 15? Negative root 150. Thought bubble. Root 150 for right there. And negative root 150 for right there. What happens when you have 150, root of 150 in this hand, and then you take it away? It disappears. And over in this hand, because I misdirected you, I have the root of 150. So what is the other term that stays? 10. What happens up top? What is 7 times 15? Calculators get grabbed. Root 105. What is 7 times 10? Root 70. Root 105 plus root 70 over 5. Now what would you do?
Simplify.
You would simplify, but 105 doesn't simplify because it's 21 times 5. 3 times 7 times 5, no pairs. What about root 70? 7 times 2 times 5. Does it simplify? No. So am I done? Yes. Everybody good?
I didn't write that.
Okay. And what's up my sleeve? The root of 150. Are we ready to go?
Why? What's with the root of 150?
Because it disappears like a magician.
But, no, I get that. But like, what was the point of the 150?
Because when you FOIL this out, you end up with positive 150, root 150, and negative root 150. So they cancel out and disappear.
So why is the negative 10 there? If they're
Because negative root 10 times positive root 10 is negative 10.
What did you say?
Oh my good gravy. 3 x plus 2 times x minus 2. Do that.
Well, you do it like FOIL.
So do it.
So it's x squared plus minus 2x plus 2x. What's the last one? Minus
What happened to the middle terms?
combine them.
Yeah, what's negative 2 plus 2?
Nothing.
Gone. Okay, now, root 15 plus root 10 times root 15 minus root 10. Do that.
You know you can also check your work after?
Yeah, do that.
I don't know if you're thinking.
You don't need to. What's the root of x times the root of x? So what's the root of 15 times the root of 15? 15. What's root 15 times negative root 10?
Is that one 150?
That is negative 150. Right? Minus root 150. What is positive root 10 times root 15? Positive root 150. And what is positive 10 times negative 10? Negative 10. Plus negative 150 plus 150.
Oh, okay.
Okay.
Two negatives.
Now we get to the actual difficult stuff. If none of this were here, what would I have to do to get rid of that root 3? I would have to times by root 3. Agreed? So what do you think I need to multiply by here? Root 3 minus root 2 is what you think will work, yes? So let's do that. 2 root 3 times root 3 is 2 times root 9. I'm going to write it all out because this is thought bubble stuff, yeah? And then
Okay, I don't mean too slow.
2 root 3 times negative root 2 is negative 2 root 6. Is everyone okay? Okay. Root 2 times root 3 is positive what? Root 6. And root 2 times root 2 is negative root 4. Yes? Did the middle terms drop out? No. So, when we had no coefficients, we could leave it the same. When we had a monomial, we could ignore the coefficient. What is different in H? It's a binomial with a coefficient. So I have to keep it. Because watch what happens now. 2 times 2 is 4 root 9, right? Minus 2 root 6. Now look what happens here. What kind of 2 root 6? Plus 2 root 6 and minus root 4. Now do the middle terms drop out? Yes. So what should you be putting right here with a star and a Mrs. Bad Crumble Cloud and whatever you need to remind yourself? If it is a root x plus b root y, what's the conjugate? I must keep both coefficients. Any coefficients must be kept, or when you distribute it out, they won't disappear. Everybody good? So, what then? We now know that we must multiply by this, yes? So the bottom, let's do it all out so nobody gets confused. 2 times 2 is 4. 3 times 3 is root 9. We know the middle terms are going to drop out. Everybody's comfortable with that, right? Do I need to do that? Do I need to actually show you the middle terms dropping out again? It's been recorded and we've talked about it a million times. You all know how to do FOIL. Do I need to show the middle terms disappearing? Okay. And then plus root 2 times negative root 2 is minus root 4. Yes? Now, up top, I have a FOIL situation. What is that one? 6 root 6. I heard someone say it. What is that one? Negative 3 root 4. We're going to write it all out. We're not going to do any simplifying in our heads. What is that one? 2 root 9. And what is that one? Negative root 6. Now simplify. Does that simplify? Yes, it does, because I got 6 root 6's there, and I'm taking away one of them. So what have I got there? 5 root 6. 5 root 6. Does that simplify? Yes, it does. What's the square root of 4? Times 3 minus 6. Does that simplify? What is it? 6. Positive or negative? Over. Does that simplify? To what? 12 minus 2. Any more simplifying here? 5 root 6. What's negative 6 plus 6? Gone. What's 12 minus 2? 10. Preston! Yeah! Bing, 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 bing! Root 6 over 2. Everybody good? All of that has been recorded. Now listen to me. You have 20 minutes left in class. When you turn to the next page, you will see 2... I'm the worst kind of liar. 4 pages of practicing this, all of this stuff. You have, it's 2 pages, 3 pages of work, and you have the answers. Because this is starting to get outside of all of your comfort zones. Even if you feel you're getting it, it's complex. All right? Do this work. If you can cram it onto this page, cram it onto this page. I don't think you can. It is totally up to you. We will be working on this for the next 2 days.
And then we have the whole weekend.
Then you have the weekend off.
Oh, so this isn't due tomorrow?
No. I thought that I didn't give the answers to this. But as I am looking right now, I have. So I can't really make it an assignment. You all got 100. Hey, you got all the answers right. Amazing! How did that happen? You didn't even show any work. You just wrote the answer. You're a genius, kid. All right. Everybody good? By the way, ladies and gentlemen, I'm a little bit saddened at the lack of parental visitation from this class. I'm a little bit sad. There are a couple of parents coming.